Greetings everyone, today we will learn first chapter, units and measurement. This would be the fourth lecture of this series. Chapter, units and measurements. Lecture 4. Yes. So in this lecture, students, I will discuss errors and basically I will discuss only theory part. So, errors. Error of a measurement. Error of a measurement. So how would you define error of a measurement? The difference in measured value of a quantity and its true value of a quantity and its true value is called error of a measurement. Error of a measurement. Okay, students. So you have meter scale, length meter scale, and you are dealing with the height of a person. You notice his height is like 2.1 meter, and it is the measured value, and his actual height is true value is 2.2 meter. So the difference between the two values is actually called the error. Sir, this is fine, but could you give formula to it? Yes, definitely. Error measured value minus true value. Okay, so this is how error is being defined here. Suppose to erase all this, I believe, this part. This would do, sir. Error analysis. So error has two parts. What are they, sir? Systematic error and error analysis has two parts. Basically, there are two parts. What are they? Systematic error and random error. Systematic error and random error. They can be removed. So systematic error is anything that comes within the system, students. So you have a formula you have created and it's supposed to work, but it is not working so much perfectly. So let me explain you here. So you add and subtract the term, that's the thing. Some terms, they can be removed. Systematic error can be removed easily. They can be removed easily. They can be removed. And these are causes are unknown. Random errors. Random errors, you don't actually hear anything, do you? So causes are unknown in this random errors. So like some malfunctioning happen within the experiment and values get changed little bit. So random errors. Causes are unknown. Causes are unknown. So what would we write here, students? Therefore hard to remove. Hard to remove. Hard to remove. So errors do not have a solution, you would ask. Of course they have a solution, students. Let's see solution. Solution. So what would you do for solution? Like I said, you add or subtract in the equation. And in this part you increase your observation. Number of measurement observation has to be increased. Number of measurement observations has to be increased. Has to be increased. This is the solution to it. Now the next part, measurements. 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 So erase this part also. Yes, I should. Measurements. Measurements. Now I will discuss measurements. What kind of measurements are there? So even measurements have kinds. Yes, basically two. One is what, beta? Students, accurate value, accurate measurement, and precise measurements. Precise measurements. Precise measurement. These are the basic two types of measurements we have. So what is the meaning of accurate measurement? Low systematic error. This goes here, that this arrow here goes here. Low systematic error. Low systematic error. So to achieve this measurement, we should have low systematic error. To achieve this, you should have low random error. Okay. To achieve accurate value, you should have low systematic error. To have precise value, you should have low random error. So how would you do this? How would you achieve this accurate value and precise value? Easy, very easy. This is being done by manipulation of system, manipulation in system of system, I would say, manipulation of system. So you add and subtract within the equation repeatability. Low random error is achieved by repeatability. This can become tough. Sometimes you have to repeat your observations again and again. Example. Yes, example would better explain this. So the example of error in a measurement, example, error in a measurement, error in a measurement. Yes, sir. You have, suppose, some quantities 5.01 centimeter, 5.02 centimeter. This becomes again what? 5.02 centimeter, and this becomes 5.01, 5.01, 5.01 centimeter. So accurate value says, according to accurate value, it's supposed to be mean value of these quantities. And how would you get these quantities mean value? So mean value we get by summing the values and dividing it by the observations. Yes, very good. So I would write x 5.01 plus 5.02 plus 5.02 plus 5.01 upon 4. Yes, very good. And what I am supposed to get now? You calculate for now. And let me check my calculations. So yes, it is 5.015. 5.015 is the number we get. So I would write x mean value 5.01 is the accurate value in this observations, and 5.015 is the precise value. Precise value. Okay. Precise value. Yes. Now we will discuss absolute error. So you in mean value or accurate value you take till significant figures, and in precise value you go as long as possible. Accurate absolute error. Absolute error. Absolute error is, students, del xn x minus xn. Okay sir, nice, but we didn't get anything, absolute error. So let me give an example. Example of this x1, example to this, del x1 is x minus x1, and this is what, 5.015, and this is what, 5.01. Okay students, so this becomes what, the student 0.05 sir, centimeter. Very good beta. So mean absolute error becomes, this is the del x1, absolute error, mean absolute error supposed to be, mean absolute error del x1 plus del x2, this goes on, and this becomes del xn upon n, number of observations, and this becomes again what is students? I'm talking about the mean absolute error here students. So you would say sir, del x1 is this, del x2 is what? Students, you put x2 here and mean remains the mean. So you put all the values or the four values, and you divide by the number 4. So you would say sir, okay sir, we get it, but little bit of help. So it is a thing. So we should write here del x 0.05, 0.05, so 0.05, 0.05, yes, and divided by 4. So del x becomes what is students? 0.1625. Oh sir, big number. Yes, very good. Representation of value becomes, within the experiment, what would you write? Representation of value. Representation value of experiment. And it should be x del x 5.015, 0.162 centimeter. Yes, this is how you would write this value in the experiment. And now propagation of errors. This is how you would represent a value in the experiment, and propagation of errors. So what is propagation of errors? So this happens sometimes. Propagation of errors, addition and subtraction. Suppose (2.02 centimeter cube). Suppose we have two cubes. Suppose we have two cubes. Yes, sir, we got your point. You have two cubes. We have two cubes here. One cube is this, and other cube is this. And this value is 4.04 centimeter cube. Okay, students. So in propagation of errors, we are discussing that what will happen to errors when we will add or subtract. When we will add or subtract between the two cubes. So let's see. So the total volume becomes volume V is equal to V1 plus V2, these two cubes, and this becomes 6.004. Okay, students. And difference in volume becomes, you calculate the difference yourself. Sir, difference V2 minus V1 I am taking, and this becomes what, students? 2.02, no, 2, no, 6, yes, 06, yes, centimeter cube. Error is supposed to be added, yes. Sir, but here it is difference and you added the thing. So let me write a certain point here. Error is always added. Wow, sir, this is amazing. We will always add the error. This is always added. Okay, error is always added. It should be then 0.6. Yes, my dear, this should be 0.6. You were right. Error is always added. Now, to the better part of the story, multiplication and division. A is equal to, oh, yes, multiplication division. Multiplication. We'll discuss multiplication. Example, area. Area is what, students, of a rectangle? Length into breadth. This becomes del A upon A, del L upon L B. Okay, students. Now the division part. Example, Z is equal to AB upon C. How would you represent the area of this thing? Think of yourself now. How would you represent the area of such an equation? You have area here, length and breadth. This is the basic representation. How do you would use of division? So it is multiplied also. Del Z, Z, del A upon A, del B upon B, del C upon C. But consider y is equal to a square b cube upon c4. Now the power part has come. What would you write then? Powers have to be dealt carefully here. Let me show you how would you deal with the powers in representation of errors. Del y upon y, 2 del A upon A, 3 del B upon B, del C upon C. Yes, I understood what you are saying. 4, sir. 4. Yes. So this is actually the powers, how you deal with the powers. They just take, you don't count powers in the errors, you count their number as a coefficient. Yes. Now the last part of the story. Percentage error. Even sir, percentage of error. So even this part exists. Yes. And you have a quantity AM, BN, CP. You have to calculate the percentage. So the percentage error becomes percentage in error is what, the students? So how we are supposed to answer this? Into 100. So could you explain this part? You wrote percentage error, you wrote an equation. How we will get this? So suppose you have a quantity y, you multiply and it is equal to what? AM, you have physical quantity A here and it is raised to the power m, suppose 2, 3, and B quantity is another quantity here and it is supposed to be raised to power n. So it actually becomes what, students? Again, the coefficient, and this Cp is again the same thing. Okay, sir, we got your point, but we want the equation. Yes, I got your point, students. M M into 100, students. Then what we would write, students? N del B del B upon B plus what, students? So P part, P del C upon C upon 100. Very good, students. Very good. Now you actually got the thing. So this is the same thing that I said earlier. Yes, so we have understood this without a doubt. It was like earlier, but you put 100 and that too even for percentage. So this becomes m% error in A, the first term, and becomes n% error in B, and C becomes p% error in C part in C. Okay, students. So this is the theory part of errors. I will stop here for now. Thank you.